So this becomes 3 by 5, this becomes 2 by 5, which is not balanced. Product of current and resistance is positive. Will be the current flowing through the resistance. First, I have to check whether the given network is balanced or not. I have to find the current through the galvanometer. This is Ig. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my previous 2 sessions, I had solved problems from the chapter Electric Current, where my focus was basically on the concepts like resistance, resistivity, EMF, internal resistance, cell, which means with simple circuits that could be analyzed using Ohm's law. But here, in my today's class, I will be solving problems from Kirchhoff's laws, the so-called network analysis. I will be using Kirchhoff's current law and Kirchhoff's voltage law. If you have gone through these sessions, ideally understood the application of KCL, KVL, and description of a Wheatstone's network. This is a very, very easy session to follow. Now, we start solving problems based on Kirchhoff's laws. The first problem. 2 cells of EMF 6 volts and 4 volts having internal resistance 3 ohms and 2 ohms are connected in parallel. The problem reads that there are 2 cells. The first cell has EMF 6 volt. The second cell has EMF 4 volt. And they have internal resistances 3 ohms and 2 ohms respectively. They are connected in parallel across an external resistance of 8 ohms in the same direction. Find the current through the cells and current through the external resistance. Here to understand, students, there are 2 cells which have an EMF of 6 volts and 4 volts respectively. andre I call this to be the first cell whose EMF is 6 volt. Second cell whose EMF is 4 volts. And they have internal resistances 3 ohms and 2 ohms. 3 ohm internal resistance of the first cell and 2 ohm internal resistance of the second cell. Now what is happening? They are sending currents I1 and I2 across 8 ohm resistor. Now to analyze, I1 is the current that is sent by the first cell. So it is flowing in this direction. This is the direction of traverse given. It comes here and it flows in this direction. Now to ascertain, to understand, is I1 positive or negative? Very clearly, by current law, I1 is positive because it is entering this node B. Node andreno, point, junction, where 2 or more conductors are connected. So I1 is entering this node. So I1 is positive. What about I2? It is the current which is sent by the second cell. Again, it is entering the node B. Again, I2 is positive. So I1 plus I2 will be the current flowing through the resistance R. So what is that I have to find out? In this problem, individually, I need to calculate I1. Individually, I need to calculate I2 and the current I1 plus I2 flowing through the 8 ohm resistor. Now all of us will identify the first loop, or what is also called mesh. A, B, E, F, again A. Loop or mesh is a closed path. From wherever you start, we end there. So A, B, E, F, A. It is a closed path. Now, what I do is, I will apply Kirchhoff's voltage law to the mesh A, B. So this is the mesh A, B, E, F, A. A, B, E, F, A. So I am applying KVL. KVL is nothing but voltage law. Where? To the mesh A, B, E, F, A. Now, first, consider the direction of I1. Is it along the direction of traverse? Yes, the rule says direction of current I1. If it is in the same direction given, then product of current and resistance becomes positive. Here I1 is flowing in the same direction given. So product of current and resistance becomes positive. Therefore here we have 3 times I1. Next, which is the other current flowing in that loop? Current through 8 ohm resistance. Which is that? I1 plus I2. It is also in the same direction given. See, in the same direction of traverse. So product of current and resistance is positive. So this is plus 8 I1 plus I2. Now let us check. Any other current in this loop? No. That should be equal to what? EMF. When is EMF positive? When it sends current from negative to positive terminal. So this is equal to 6 or 3 times I1 plus 8 times I1 plus 8 times I2 is equal to 6. 8 plus 3, 11 times I1 plus 8 times I2 is equal to 6. And I call this equation 1. Similarly, I will apply Kirchhoff's voltage law to this second mesh. Which is the second mesh? B, E, D, C, B. ಎಲ್ಲಿಂದ ಶುರು ಮಾಡ್ತೀರಾ ಅಲ್ಲಿಗೆ ಹೋಗಿ ಮುಟ್ಬೇಕು. B, E, D, C, B. So B, E, D, C, B. Now again, I2 is the current. Again, it is in the same direction given. I2 is the current flowing in the same direction of traverse. Product of current and resistance is positive. So it is 2 times I2. Again plus 8. I1 plus I2. Let us check for the EMF. Again, the second cell is also sending current from negative to positive terminal. So EMF is positive. So on simplification, this is 8 times I1 plus 10 times I2 is equal to 4. I call this equation 2. Now I have to simplify. I have got 2 linear equations. simultaneous equations, simplify them, we will arrive at I1 and I2. So for simplification, what is that we do? We will multiply the first equation by 10, the second equation by 8. So on multiplication, 11 into 10 is 110 I1 plus 80 I2 equals 60. I have just multiplied the first equation by 10. 11 into 10, 110. 8 into 10, 80. 6 into 10, 60. Multiply this with 8. So 64 I1 plus 80 I2 is equal to 40. Simple simplification. From this, I1 turns out to be 0.61 ampere. So this simplification you will be doing, simplifying I1 equals 0.61 ampere. Now substitute I1 in any one of the equations. So substituting for I1, I2 turns out to be minus 0.09 ampere. This negative sign for I2 means current is flowing in a direction opposite that we have taken. Kirchhoff's laws are a set of conventions. It is not that direction of current should be as that. Mathematically, see, I2 is turning negative. So now, from this, I equals I1 plus I2, 0.61 minus 0.09. So the answer for I is 0.52 amperes. So students, very simple, where we have used a set of laws called Kirchhoff's laws, knowing the convention, knowing the rules, just frame equations, two linear equations, simplify. The simplification can also happen through something called Kramer's rule. But since you people are not exposed to that, I don't use Kramer's rule. We are familiar with simultaneous equations, so we do that. The next one. ಈ ಚಿತ್ರನ ಈ ತರ ಸರ್ಕ್ಯೂಟ್ ನ ಎಲ್ಲಾದ್ರೂ ನೋಡಿದೀರಾ? ಇದನ್ನೇ ವೀಟ್ ಸ್ಟೋನ್ಸ್ ನೆಟ್ವರ್ಕ್ ಅಂತ ಓದಿದ್ವಿ. ಏನ್ ವೀಟ್ ಸ್ಟೋನ್ಸ್ ನೆಟ್ವರ್ಕ್ ಅಂದ್ರೆ, there will be 4 resistors connected in an cyclic order. When do you say Wheatstone's network is balanced? When Ig is equal to 0. No current flows through this galvanometer. And the balancing condition in baradve, P by Q equals R by S. So this was the balancing condition. Here you have 2 ohm resistance. Here you have 3 ohm resistance, 1 ohm resistance, 4 ohm resistance. Now, I have to find the current through the galvanometer. This is Ig, current flowing through the galvanometer has to be found out. Now, I will first consider the mesh A, B, D, A. See, ಈ ಪಾರ್ಟ್ ನ ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಗಮನ ಇಟ್ಟು ನೋಡಿ ಯಾವ ರೀತಿ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಆಗುತ್ತೆ. ಓನ್ಲಿ ದಿಸ್ ಪಾರ್ಟ್ ಆಫ್ ದಿ ಮೆಶ್ ಎ ಬಿ ಡಿ ಎ. ಸೊ ಅಗೇನ್ I apply voltage law to the mesh A, B, D, A. Now, look at this direction. So this is the conventional direction of traverse that is given. I1 na nodi, is it in the same direction of traverse? Yes, I1 is in the same direction, which means product of current and resistance is positive. So I have 2 times I1. Next, which is the current flowing through this part of the mesh? Ig. Is Ig positive or negative? It is positive. Why? Again, Ig is also flowing in the same direction. So we have plus 10 times Ig. The other current that is flowing in this mesh is I2, but very clearly I2 is opposite to the direction given. ಆ ಎರಡು arrow mark ಗಳು ನೋಡಿ, I2 is opposite to this arrow mark. So product of current and resistance is negative now. So minus I2 is equal to EMF. How much is the EMF? He says EMF is 2 volts. But please to understand, students, this EMF of 2 volts is for this entire circuit. I have to get an EMF in the mesh I have considered. Do I have EMF in the mesh considered? No, which means this EMF is 0. I call this equation 1. Next ಏನ್ ಮಾಡ್ತೀನಿ? Apply KVL to the next mesh. B, C, D, B. Interesting here. So I will apply KVL to B, C, D, B. Now, how did this current become I1 minus Ig? Very simple. What is the current flowing through this node? I1 is entering the node. Therefore, I1 is positive. Ig is coming out of the node B. Therefore, it is negative. Hence, at B, the current flowing is I1 minus Ig. So, again, I1 minus Ig, this is the direction of traverse. The direction of I1 minus Ig is along the direction given. So, product of current and resistance is positive. So, we have 3 I1 minus Ig. Now, what about Ig now? See, Ig is coming down, but the direction of traverse is up. So, Ig is opposite to the direction of traverse. So, product of current and resistance is negative. So, this is minus 10 times Ig. Again, how do I get I2 plus Ig? I2 is the current entering the node. So, I2 is positive. Again, Ig is the current coming towards D, entering D. Therefore, it's positive. So, I2 plus Ig. 4 ohms. Now, look here. I2 plus Ig, the direction. It is opposite to the direction of traverse. I2 plus Ig is flowing in the opposite direction. So, the product again becomes negative. So, this is minus 4 I2 plus Ig. Again, do I have an EMF in that part of the mesh? No. So, this is 0. So, on simplification, 3I1 minus 3Ig minus 10Ig minus 4I2 minus 4Ig is equal to 0. Or this is 3 times I1 minus 3 minus 10 minus 13 minus 4 minus 17 Ig minus 4 I2 is equal to 0. And this frames equation 2. Did I have any more loop in the circuit or mesh in the circuit? Observe. A, D, C, E, A. This is also a closed path. Alva observe Madi. A, D, C, E, A. So again, I'll apply KVL there. A, D, E, A. So that is CA, A, C, E, A. So on application, I2. Now this is the direction of traverse. I2 is along the direction, same direction. So we have 1 times I2. Next, again I2 plus Ig in the same direction. So plus 4 I2 plus Ig, which is equal to 2. Or this is 5 I2 plus 4 Ig is equal to 2. Now again I have framed the equations. So solving equation 1 and 2. So when I solve equation 1 and 2, I get one of the parameters. For suppose I2, substitute for I2 here, you get the value of Ij. So here, Ig turns out to be minus 0.03 amperes. So on simplification, the current flowing through the galvanometer is 0.03. The next one, again very simple, again Wheatstone's network. So this is based on Wheatstone's network. So P is given to be 12 ohms, Q is given to be 15 ohms, R is given to be 4 ohms, so cyclic 4 ohms, and S is given to be 10 ohms. So P, Q, R, S, P is 12 ohms, Q is 15 ohms, S is 10 ohms, R is 4 ohms. First I have to check whether the given network is balanced or not. So for the balance of Wheatstone's network, P by Q should be R divided by S. So P by Q, 12 by 15, 12 by 15, R divided by S, 4 by 10. So this is clearly not equal. Therefore, the network is not balanced because the balancing condition is not proved. So this becomes 3 by 5, this becomes 2 by 5, which is not balanced. Now he says, if the network is not balanced, what should be the resistance? Calculate the resistance to be connected in parallel with the resistance of 10 ohms to balance the network. The problem says, if the network is not balanced, calculate or find out the resistance to be connected in parallel with resistance of 10 ohms. So now we have to connect a resistance of 10 ohms in parallel, so that now we have P by Q equals R. Now yes, observe, S and X are connected in parallel. So effective resistance comes into picture. So they are connected in parallel. S by X divided by S plus X. Now substitute. 12 by 15 equals 4 S into X, 10X. So when you substitute for X here, X turns out to be 10 ohms. See? So in simple terms, using a few concepts, few equations, I have solved the problems on Kirchhoff's laws. Next, I start with wave optics. Until then, have a nice time. Thank you.